Alrighty. Good afternoon or good morning, everybody, depending on where you are. My name is Tricia Palmer. I am the co-chair of the NWA Professional Development Committee, and welcome to February Webinar Wednesday. Just a couple of logistical things as we get started. If you have any questions, you are free to use the little questions part of GoToMeeting, and we will ask them at the end. Alternatively, you can use the hashtag NWAWebWed. That's hashtag NWAWEBWED at any time, and I will try to get to all those questions at the end and ask them of our speaker. So, just to introduce our speaker really quickly, we have Kevin Fuel with us today, and he will be presenting Next Generation Satellite RGB Dust Imagery, which led to some operational changes at NWS Albuquerque. And this is also an NWA Journal of Operational Meteorology article, so feel free to peruse through that at your leisure. A little bit about Kevin. He graduated from Purdue with his MS in Atmospheric Science in '97, and while he was there, he concentrated on tropical meteorology. After that, he was a UCAR visiting scientist at the National Ocean Service from '98 to 2000, and there he implemented the LAPS model over the Chesapeake Bay. He then moved on to UCAR Comet until 2007, and there he developed training materials for derived sounding parameters within AWIPS, marine meteorology, rip currents, and some other topics. Since 2007, he's been at NASA Sport via the University of Alabama Huntsville as part of the Transition and Training Group. His focus has been on current NASA satellite instruments to diagnose various weather phenomena, and most recently the use of these in JPSS products as part of the NOAA Satellite Proving Ground as a proxy to the future GOES era, which we are all very excited about. So, without further ado, I will go ahead and pass this along to Kevin Fuel. I am making you the presenter, Kevin, and you can take over at your leisure. Thank you. I see your presenter view. I see the presenter view, not the actual presentation.
Okay, let me try to...
There.
That looks good?
Yep.
Okay. All right. Well, thank you very much for the opportunity and for the introduction. So obviously we have the link to the article here, and here's the product that we're going to be talking about today. So the purpose today really is to go over that JOM article regarding the application of the Dust RGB there at the Albuquerque Forecast Office, and hopefully demonstrate to you some of the value that they found through our transition activities at NASA Sport in collaboration with them and within this NOAA Satellite Proving Ground. So I'm hoping that today, or my desired outcome essentially, is that you have a bit of a greater appreciation for these RGB type products, in particular the Dust RGB products, and often these are referred to as multi-channel or multispectral products, and how they can have a benefit over like traditional single channel. Hopefully you'll have a little increase in understanding of what RGBs are in general, and sort of get you ready or sort of get you excited about this new era of geostationary imagers that we're about to go into. Besides from myself, Brian Geyer is co-author on the paper, and Brian was extremely instrumental in writing that paper and gathering information for the cases. I really wish he could be here today to present some of this to you. He did extraordinary work there at Albuquerque, and encouraging the other staff members as well was Deidre Kahn, who's with us today and will be able to provide some feedback and input at times, I hope. She was instrumental in one of the cases in the paper. She was the SUE at the time and has retired since then. Also, two people associated with NASA Sport, Andrew Moulton and Nicholas Elmer. Andrew's one of the co-leads of the Sport program and has expertise in a variety of areas, including cloud microphysics. And Nicholas is a University of Alabama Huntsville graduate student who was doing some work at the time on RGB limit and bias correction. So the presentation is going to go over a few topics here as an overview in terms of Sport and Albuquerque and the RGB, and then we'll go over three of the cases that were in the paper itself, and then a little short summary in the future. So I'm not going to keep you waiting. I'm just going to show you right away a nice example of the Dust RGB loop. Hopefully that works for you. I just started that. The dust actually turns out in sort of this red magenta color, and this is essentially the future of imagery here that we see from the Himawari 8 advanced imager. This is nearly identical to essentially what GOES 16 or GOES R as we used to call it will be able to provide, as well as GOES S. So we're hoping to show you how essentially the polar orbiter versions of this product that were used by Albuquerque had value in operations, and hence how this geostationary product, which I'm sure everyone's looking forward to, will have even more impact. So if you're anxious to see some of these types of imagery from existing geostationary satellites that can do this, such as Meteosat and the Japanese Himawari satellite, there's some different sites down here I listed in addition to our own NASA Sport site, where we'll have both the geostationary and low Earth orbiter versions of the products as well. So a little background, if you're not familiar with the Albuquerque WFO, obviously a fairly large county warning area for them with diverse terrain shown in this graphic here. And some of the major observation sites are on that graphic itself, so you can see fairly vast areas without observations, so it can be difficult there to know what's going on, and obviously remote sensing type data is very important. In addition, there's some gaps, if you will, in radar, either due to beam blockage or just site locations for the various radar, which can also make life there in Albuquerque a little difficult in terms of keeping track of some of these hazards. So at their office there, they have quite a range of issues that they have to deal with, anything from winter weather, especially with the higher terrain that they have, severe thunderstorms during the monsoonal season, as well as flash floods, fire weather, fog type of issues related to aviation and public safety, and of course blowing dust that we're going to talk about today. So a little bit about SPORT, if you're not familiar with it. It's the Short-Term Prediction, Research, and Transition Center. And essentially SPORT is focused on trying to transition unique NASA and NOAA observations and capabilities into the operational community for really the regional and local type scale. We started back in 2002 and had some products going into the National Weather Service AWIP system in 2003. And a large part of the NOAA components really came in around 2009, where we started to participate in the satellite proving ground activities. So the main benefit that SPORT is trying to provide is to demonstrate these various NASA and NOAA capabilities, which are considered maybe experimental products, to specific weather applications and societal benefits or needs. And we're trying to use some of these things, as we're going to demonstrate here, to prepare users for next generation type instrumentation, in particular imagers and other instruments on the JPSS series, which is the polar orbiting series, and then of course the GOES-R, GOES-16, and GOES-S type series. In addition to remote sensing, satellite sort of expertise, some other areas of expertise listed over here on the right. In particular, the lighting is very exciting, as the GOES-16 will have the geostationary lightning mapper, and SPORT has Jeffrey Stano here, who is the GLM liaison, working with a variety of groups throughout the Weather Service to transition into that new era of being able to detect total lightning from space. So we're very excited about that. We're very involved in that area. In addition, there's some things related to modeling and data assimilation, post-disaster imagery, decision support systems relates to creating various tools and code within the user's display system. And then I tend to work a little bit more in the transition training and assessment area, where we're providing some of these experimental products, providing training on those products, assessing how they impact operations, all in collaboration with the users, and then going back through that same cycle again based on user feedback. If you're not familiar with the RGB topic or concept in general, I'm just going to give you a brief introduction here. And we're showing here the nighttime microphysics RGB over here on the right from Himawari, and you can see its range of colors, and you could be imagining, what does all this mean? And it does take a little interpretation and a little time to learn these things. So some of the reasons why these things happened was because the Meteosat second generation from EUMETSAT was going to increase their imagery capabilities many times over, to increase it to 12 channels. This was back in the early 2000s. And they were trying to come up with an efficient tool to be able to use these in operations. And so anything that's not really a true color image that you would see with your eye is referred to sort of as false color, and we often just refer to those as RGB images or composites. EUMETSAT, when they were going through this process, developed sort of a best practices suite of RGB recipes, and we're going to be using their recipe for the Dust RGB in these examples. If you want more details on sort of what RGBs are and things, I would highly recommend you go through the UCAR comment module about RGB products explained. It's very good, and I think you'll really enjoy that. Some things to keep in mind about RGBs, though, is that essentially if you have black, that's no color, and white would be all colors. In other words, all colors being contributed from each of the three components. And also, dark colors are going to be a little amount of color. Bright colors are going to be a large amount. So somebody might see like a dark red and think, oh, wow, that's an intense red right there. That must be a lot of red. Well, actually, it's a small amount of red when it's a very dark color like that. One thing I would highly suggest if you start to look at this kind of imagery is to be able to try to sample it in some way so that you can see the individual components, the individual red, green, and blue contributions that go into the resulting pixel. It will greatly help you understand how much is being contributed from each component and how to interpret the image. Another thing to keep in mind is that these aren't just three channels all put together and mixed around in some paint can. Essentially, there is a maximum and minimum threshold per color component that's used to provide consistency when you're trying to interpret these various features, especially across latitudes and across seasons. You can imagine the range of, for example, the long wave IR brightness temperature difference may change depending if you're at high latitude, low latitude, and whether you're in winter or summer. So this provides consistency in terms of, you know, that red means, this shade of red means the same thing now, and also means it 6 months from now. So on the right-hand side, you can see the nighttime microphysics has two actual differences in the red and green component, and a single channel in the blue component here, and you can see the ranges there. We're going to look at the dust RGB here in detail, and it's not too far off from this right here. And you might notice that essentially this long wave in the blue is something you're probably familiar with. It's just long wave IR. This long wave minus short wave is a difference that you're probably used to determine or differentiate low water clouds from higher and mid ice clouds. And you might not be as familiar with the red, but essentially we're going to have a very similar set of channels being used for the dust RGB. So here's a nice table to try to sort of help explain this a little bit. And essentially we have the color component, the band or band difference, what it physically relates to, and then the right two columns are sort of, if you have a large amount of that color on the very right, that's what it's going to give you. If you have a little, that's what it's going to relate to. If you have a little amount of color, that's what the black text is. So let's just start on the bottom here, the blue thermal channel, as we said. Essentially, if you have a lot of blue, that means it's a warm surface. If you have little blue contributing, it's cold surface. The green here is changing a little bit from the nighttime microphysics. We've replaced the shortwave with this 8.7 channel, and that's essentially to get away from the contamination of solar reflectance during the day with that difference. And this difference physically relates to like particle phase, essentially. So very little contribution is for ice particles and or dust. We actually have a special situation of where you have extreme high green values, which is when you have thin clouds over the desert region. The emission characteristics over the desert region are different, and it kind of overwhelms the relationship. But the text here in the middle in italics basically just mentions that we have a medium amount of green that tends to be with water-based clouds. The red is a little bit different. You might not be used to this, but the 12 micron minus 10.8 essentially is related to optical thickness, and we use this kind of as a proxy to cloud thickness. However, for this particular component, aerosols have a different spectral response, and essentially aerosols display greater absorption at the 10.8 than at 12 microns. This means that the 12 microns will have essentially a warmer brightness temperature, and the difference results in a large positive value in the range. However, the opposite is true for like thin clouds, such as cirrus. In the case of cirrus, you have less 12 micron pass through the cloud than 10.8. In other words, you have 12 micron brightness temperature, which is colder than the 10.8, resulting in a negative difference and a low amount of red, or essentially a dark red. So that's a difficult thing maybe to kind of keep in your head as you're going through operations. One of the things that we did is provide what I refer to as a quick guide to the forecasters at Albuquerque. It doesn't look exactly, the one that we gave them doesn't look exactly like what you see here, but we essentially have modified the quick guide over time. And this graphic here is essentially the back side of the quick guide itself. That graph I showed you on the previous slide is on the front side of the quick guide to help remind people what the components are. This is sort of an interpretation graphic, if you will, so that you can look at it and quickly say, oh, dust is in this magenta color, I see it number 1 in this box on the graphic. And for example, number 6 is cold, thick clouds. I see those in various places in this red, dark red sort of shade. And it gives somebody a quick reference as to what some of these features are as they're sitting there in operation trying to interpret the imagery and apply it. So that's sort of the basics overview, and we're going to go into the cases at this point. We're going to look at 3 different cases here documented between 2012 and 2014. One on a mesoscale event, another on a large-scale event that had decision support impacts to the public and local transportation, and another large-scale event that actually went into the nighttime period where the dust RGB was still valuable for both day and night. Overall, I just want you to remember, essentially as we go through this, that using this product over this time period increased the confidence of the forecasters and led to changes in procedures to better communicate the dust hazards to the public and the aviation communities, and we'll go over that in a little bit more detail at the end. So first, the mesoscale example, which is actually a case from the Farmington, New Mexico area, which is in the upper left portion of the graphic there. This is the one that Deidre was instrumental in documenting and actually was working that day. Let me just mention here that the table on the right might start to look a little busy, but essentially the table here is to provide in the black text the observations from the Farmington site, and then the purple text is the TAF, or Terminal Aerodrome Forecast, for that site. Yes. So essentially, as background, we had a broad trough that was over the west coast and southwesterly flow over New Mexico, also with wind advisories in the very northeast corner of the state there, and nothing was really anticipated for the west-northwest area at this time. As we see here, we had the 12 UTC TAF, was updated slightly with some higher wind gusts, but it was keeping clear skies in the forecast there for 18Z. The 16Z observation was showing essentially winds out of the south, a little gusty there, and 10 miles visibility, but clear. So if we were to look at the GOES visible imagery sort of as a whole over the state there, I'm going to loop this, hopefully it plays for you. This is a loop from 17 to 22 UTC. Most of the clouds are on the eastern half, moving to the east, northeast. Not a lot going on the western side, but if we're looking at the Farmington area, we have sort of a little wave cloud of some sort of pops up at some point in that time period, and looping through it twice there. But not a whole lot of note at that particular time. Okay, so essentially at 1700Z there, we had unanticipated sealing that prompted the forecaster on staff there, which is Deidre, to check the visible and IR imagery. It appeared to indicate that there was clear skies, so there was some question as to whether the observation of this haze, blowing dust, and now this sealing was actually correct. The visible imagery kind of hinted at something, but it wasn't quite so clear to be able to see it there. So essentially, at 18Z, the TAP that was issued there maintained the VFR conditions through 2100Z, but there was considerable uncertainty. So if we take a little closer look here and we zoom in to the Farmington location in the northwest portion of New Mexico there, I'm going to play the loop there, and you might get a little bit better sense as to something's going on there. And again, you see sort of little orographic clouds that pop up, but it's kind of difficult to make out what's going on there. So we move ahead to 19 UTC here, and we can see essentially that the ceiling has lowered to 3,200 feet, while the visibility has gone back up to 10 statute miles. We have essentially over here on the left the MODIS Dust RGB at 1819, which actually shows in magenta here a nice little narrow dust plume from really what was an unknown source region. And we have a little inset on the bottom left there that shows in the dark blue, it's almost black, this little orographic cloud that was occurring, and a little bit better view of the magenta dust plume that was going on in that particular location. So essentially, even though there was some uncertainty there about what the visible is showing, the Dust RGB helped to validate the observations that were there and really provided a benefit by showing the aerial extent. And again, I want to emphasize that while Deidre was working this particular event, she emphasized that that was not really a known source region for dust at that time. Okay, at 20 UTC, we have the winds somewhat subsiding back to 12, gusting 16, and actually veering a little bit, so potentially going away from that source region in terms of directing it towards Farmington, but we still have a ceiling that lowered to 2,800 feet at that particular time. And then the tab was amended just prior to 2,100 UTC for these MVFR ceilings. So we can see here on the bottom part of the graphic there, an amendment for broken 3,000 going on. If we look at the next Dust RGB pass that came over, arrived somewhere around 2,100, but it's valid for about 20Z, we can now see that we have essentially the drift downwind of the dust plume that was affecting the Farmington area, although there's still some amount of dust there that we can't maybe necessarily see as well in the imagery because something at the observation side is still reporting a ceiling of 2,800 feet broken. And we also see a new little plume that has developed within south central Colorado. So that was the mesoscale case. So I want to look at now a large scale event that happened. And you would think in this particular event, perhaps there's going to be a bit more opportunity to use GOES imagery since it is large scale and it might be a little bit easier to see. But I want to point out that the Dust RGB imagery in this particular case really provided enhanced situational awareness, in particular of the location of not only the major dust plume that was occurring that you can see here, but also some of the smaller areas of dust that are also pointed out in the graphic on the right. And again, we're going to have impacts here to visibility and ceiling conditions, in particular at Roswell, and this event goes into the nighttime period where we can continue to use this product to monitor dust. So for this particular case, April 14th, so we moved ahead just a little bit, still in 2012. We have a surface trough that deepened along the Front Range due to this upper level low that's over the Great Basin. We had a large area that was underneath a high wind warning in the eastern 2/3 of their county warning area for speeds of 35 knots to potentially 60 knot gusts. They were experiencing at the time severe to exceptional drought, particularly in the southeastern part of the state there. And those conditions actually persisted through 2013 and 2014. And the observations at 1,800 UTC already showed winds at these various observation sites of 25 to 40 knots, many of them with clear sky or only scattered conditions. So instead of showing you more GOES imagery at this particular juncture or this case, I wanted to look at a MODIS True Color RGB because perhaps with some of these clouds in the area, it would be more advantageous to have a true color type product. And here we can definitely see some sort of dust plume occurring here along the Mexican border with New Mexico. But essentially, some of the underlying land surface is still fairly dry. It's still not very green, so obviously the dust does not contrast all that well with the underlying surface. And in some respects, still looks like a thin cloud. On the right-hand side, the 2033 UTC Dust RGB, however, really shows the major dust plume quite well, and its impact on the Sierra Blanca airport is going to be quite evident as well. But in addition to that, we have dust mixed in with some of the clouds in the upper left, which would be very difficult to see not only in the GOES, but also the True Color RGB imagery. And we have two other dust plumes in eastern New Mexico and West Texas as well, which show up nicely, but again, the contrast with the underlying surface, the true color, really prevents us from seeing those. Well, pause every once in a while, I'll take a little sip of water. So let's consider the afternoon series of events that happened here. Here's the 2033 Dust RGB imagery with Roswell and Tucumcari and Sierra Blanca noted. And we continued to have Southwesterly winds increase ahead of this cold front, and at 2035 UTC, the Sierra Blanca visibility was reduced to 2.5 statute miles. Let's see. Later we have the 2033 Dust RGB arrives and is used actually to make a graphic cast, which was including a variety of text explanations of what was going to be happening with the event, and included the imagery for the public to see on the website to better understand where the impacts were going to be. So that image, in addition to some of the observations that were occurring, provided increased confidence to the forecasters that there were going to be impacts at some of these TAP sites like Tucumcari and Roswell. So for Roswell's 18Z TAP had VFR conditions forecasted for the entire period, essentially. However, at 1951, visibility started to become somewhat reduced to 8 statute miles and continued almost all the way up to 0Z. And just before 0Z, as the forecaster on shift was creating the TAP for Roswell, the visibility just plummeted to 2.5 statute miles with 2,800 foot ceiling occurring. So this prompted the forecaster to include a temporary section, which is going to span from 0 to 2Z essentially for some IFR conditions that were anticipated at that time. And essentially the observations after that period at 251 did return to VFR conditions, but were IFR during that time period. So a nice impact there of the Dust RGB providing some guidance there, in addition to the observations that there was going to be some impact. This event did persist into the night. The Dust RGB continues to be a viable analysis tool even during this time period when the visible imagery is obviously not available, and some of the single channel IR imagery is likely not going to provide the same sort of analysis or good analysis where the dust is actually occurring. As the plume becomes more widespread behind the front, the Dust RGB is confirmed by various surface observations, as we see the $sign in parts of West Texas, and we see some haze being reported in other parts of West Texas in the lower part of the image. And then behind that, further to the west, we have clear skies being reported at Tucumcari now and Roswell location. All right. So also note that we have sort of a strong contrast between the dust in magenta and this thick cold cloud that's associated with the front over here to the right side of the image. So essentially the extent of the dust could be analyzed well in the cloud-free areas, and it provides a little bit of insight regarding where dust may be under some of the adjacent clouds. All right, so a little summary here of sort of what we've seen so far really is the Dust RGB able to help improve some of the timing of the onset, duration, and termination of the dust for various TAP sites and in different events. The dust RGB was available at night when traditional visible imagery is no longer relevant. Spatial coverage in the large-scale event was easier to see than using some of the GOES visible or true color RGB type imagery. The 2033 Dust RGB, along with some of the upstream observations, could have resulted in an amendment to the 18Z TAF. The arrival of that Dust RGB was really around 2130 UTC, and so it is possible that there could have been some increased lead time there based on the deteriorating conditions and the RGB itself that might have provided an additional up to 3 hours. So that's not a criticism by me. That's sort of a self-analysis by Brian and others there at Albuquerque who were part of developing the paper and writing up the case, that they looked back on that case and said, yeah, we might have been able to increase lead time there by using that imagery a little bit better. Third case here is related to decision support, and this is kind of jumping ahead now. We've had experience at Albuquerque in 2012 and 2013, and we're getting into spring of 2014 here. March 11th case, as a front's going to move southward along eastern New Mexico behind an existing low pressure, or I'm sorry, an exiting low pressure area. High wind warnings are in effect for eastern New Mexico, and the dust was anticipated at this time. Again, remember we have drought conditions still persisting at this time. The ghost visible imagery does have some streaks in it that you can see in southeast Colorado, suggesting that we have dust in the area. And we have two station observation locations up here, the La Junta and Colorado and Lamar. If we take a look at some of the details of those, at roughly 1700 UTC, the Lamar visibility fell to 5 statute miles and a 2,700 foot ceiling, while La Junta was at 10 statute miles and clear. So these are relatively close together locations, and within that hour there, they had pretty different conditions going on. But an hour later, there at 1800 Z, we have Lamar down to 3 statute miles and 2,300 feet, and La Junta at 2.5 now and 1,900 feet. So if we put on the 1801 dust RGB that occurred, we can clearly see the magenta area there, showing the extent and location of the dust plume. Helps to confirm some of the observations that were going on there. So these ceilings of visibility were not due to some sort of cloud or fog restriction or something like that. Also, we can differentiate the magenta dust signature here from some of the mid-level thin clouds in dark purple that are out ahead of that feature. Okay, so here's some of the important aspects here as we jump ahead to the MODIS dust RGB at 1941, which shows the dust continuing to move southward and entering into New Mexico now. Shortly after receiving this particular image, the Clayton, New Mexico visibility and ceiling height began to decrease, and that's the observations kind of in the center of this 1941 image on the left. That actually at that particular time, the OB had 10 statute miles and clear. So then around 2100 Z, a pass from the SUMI NPP Veers imager, which is shown on the right, arrived and was valid at 2019 Z. So these two images here nicely allowed forecasters to use this tool within AWIPS, which is referred to as the distance speed bearing tool, to estimate the timing of the impacts to Interstate 40, which is depicted in the right-hand graphic about 2/3 of the way down the graphic there. And they essentially created this graphic cast again to put onto the website, where they indicated the timing of that dust front, if you will, or the anticipated timing around 6 p.m. of where that was going to be located. So that particular graphic cast not only informed the public, but actually, according to Brian Deidre, was kind of used internally to help show the demonstration. I'm sorry, to help show the value of the product to other staff there at Albuquerque, as well as prompting collaborations with the New Mexico Department of Transportation. So if we move a little bit more into talking about the Decision Support Services Framework thing here, that graphic cast was used to brief the New Mexico Department of Transportation. However, the forecasters who were going to initiate that with the Traffic Management Center did wait a little bit to see some of the other surface observations and the changes in the visibility that were going to go on with them to make sure that they understood the evolution of that blowing dust event. So, for example, at Tucumcari, at 2258, visibility fell to 1.5 statute miles, and then again 4 minutes later fell to 3/4 of a mile and remained there until nearly 0 Z. So the briefing with the Traffic Management Center took place very close to that 0 Z point after seeing some of those observations occur. And the Traffic Management Center was able to use those dynamic message signs that they have strategically placed along the Interstate 40 to warn the public about this sort of impending event and potential decrease in visibilities along the highway there. So sort of circling in yellow here, the graphic that's from their website showing the portion of the highway that was highlighted for potentially having this hazard, and some of the text that they had there talking about the reduction in visibility that was expected. And then I believe somebody provided this photo on the bottom right to the Albuquerque office related to that particular event and what it looked like from the air. So the big deal with this really, and Deidre will be able to talk to this probably at the end very nicely, is that this was really one of the first documented decision support activities for Albuquerque, specifically related to communicating a dust event approaching an interstate. And actually, Brian Geyer did have this example in his presentation at AMS in 2015, which obviously is recorded, and you could probably listen to him speak about that a little bit more. So an impact summary here for this case is that the 2019 Dust RGB, projected a nice 2 to 3 hour lead time in combination with the other image from Modus earlier regarding impacts to Interstate 40, and provided forecasters with an improved extent and evolution of the blowing dust compared to things like GOES visible single channel. These multiple passes, allowed exposure of the Dust RGB capabilities within AWIPS to a wider audience, both there at Albuquerque and the Department of Transportation. And again, sort of in a hindcast mode, sort of a self-analysis by those at Albuquerque. In hindsight, the briefing to the Traffic Management Center could have been done a little bit earlier, and it's kind of considered a lesson learned. And so, in the future, perhaps a little bit more weight could be given to the RGB imagery and what it provides. And you can imagine how this is going to change and how it's going to impact operations once it's in a geostationary format. So we mentioned earlier at the start of the talk there that there were these policy changes that happened, and so I'm just going to take text straight out of the publication there, so I don't have to mix words with it, and just read to you this here. So before the March 11th event that we just looked at, case 3 here, Albuquerque had never issued warning or advisory hazard products for blowing dust as specified criteria had not been readily observed, and there was no viable method for detection across the data void region. In addition, blowing dust impacts prior to 2014 were relayed as complementary information in high wind warnings and wind advisories per the NWS documentation of, and procedures. So during the remaining spring 2014, the Dust RGB product was deemed by management as a viable tool, now with both Modus and VIIRS, to provide passes, and in the future with GOES-R, or current GOES 16, as you might know it, to assist forecasters in delivering the type of decision support services presented by these cases that we've just seen here. So this allowed the Albuquerque forecasters to begin issuing specific standalone blowing dust advisories and dust storm warning. And Albuquerque issued its first blowing dust advisory on the 30th of March, just later on that month, and then another on the 27th of April, and also issued their first dust storm warning on the 29th of April, 2014. So you might be thinking, well, I'm not in Albuquerque, it doesn't really matter about this product, I'm not going to use it, I'm not in the Southwest. And there are other applications, and there are probably going to be other folks in the West who will find this useful. So on the left, we have an example from Alaska where we had some ash and dust that actually literally sits on the ground from a past eruption, and when high wind happens to come by before it's covered with snow, you actually get this plume that that goes across Kodiak Island, I believe that is. And as you know, in Alaska, there's a lot of aviation, a lot of local aviation, and flying through this, whether it's dust or ash, would probably not be a whole lot of fun. In Texas, in addition to seeing dust and things like that, there's actually a change that occurs between dry air and moist air, clear cloud-free regions, related to the change in density that occurs there between very dry and very moist air. That affects the long-wave IR, and the long-wave IR is in each component of the dust RGB, as we saw in a previous slide. And so it affects the resulting color, and you can actually see the dry line. And when you can start to see these sort of features, you realize they're not just a straight linear line. They have a lot of different wrinkles and turns, and you'll be able to analyze this in the GOES 16 era in fine detail. And here, hopefully, there's an animation from Severi that's going to play. It's about a 5-day loop of the dust RGB from the Meteosat second generation, showing a large plume that starts over Africa and travels over the eastern Atlantic there and eventually makes its way all the way across the Atlantic and impacts the Lesser Antilles and San Juan. And we've actually had some interactions with the Miami forecast office when some of these really major dust events come over and there's this haze that occurs. They can actually get calls about this from the media, and sometimes we can actually see remnants of this sort of feature in the dust RGB. This is geostationary satellite. I'm just going to mention that uses for things like MODIS and VIIRS will probably still remain as we go into the new GOES era, simply because as you go to higher latitudes, the viewing angle for GOES becomes pretty steep, and MODIS and VIIRS types of imagery do provide nice value. In particular, in Alaska, we've seen them mention various RGBs in their area forecast discussions on a nearly daily and weekly basis. Okay, so really to summarize, and again, this is sort of the future here that we see over on the right of from Himawari Advanced Baseline. The Himawari Advanced Imager, which is very much like the GOES 16 Advanced Baseline Imager. That essentially dust plume detection tracking is improved overall over the traditional GOES single channels. The areas to be warned can be reduced by being able to see the spatial extent and location of these dust plumes. You can track them even on a very small scale, and in particular at night. You can easily differentiate them from clouds and various surface features. And over time, the use of the dust RGB really resulted in a policy change for the TAF ceilings and public advisories and warnings, at least by the Albuquerque WFO. Decision support improved via this information being passed along to state roadway officials, and you can imagine, there's other folks that would relay this information regarding air quality type of issues if it was something that was near the ground. And we really hope and we really feel that the folks at Albuquerque who have been exposed to this kind of product via NASA Sports transition collaborations are going to be better prepared for the GOES R, now what we call GOES 16 era, and future GOES S. GOES 16 essentially is going to allow the UMETSAT best practices RGBs like this dust RGB that we've seen here, and you can definitely expect that there's going to be more RGBs to come besides for the ones that are in the best practices. There's a number of new water vapor channels with GOES 16 that will likely find their way into some sort of RGB. There may be impacts in the air quality area, for example, as well. I'm sure there's been a lot of information for you, and it's difficult to absorb all this, so I'm just going to remind you that on the sport training page we have this interactive quick guide, which is on the dust RGB specifically, and it has the interpretation image you see on the lower right available with it. So this is a browser-based sort of item that anybody can access and use locally on their own PC. In addition, the cases that we looked at today, the graphic on the lower left represents what I refer to as a micro lesson, which is less than 8 minutes of audio that describe each of the cases, and those will be on the training page as well. So I think that's all I have here right at the end. So if we have any questions, I'll be glad to take any of those.
All right, if there are any questions, you can ask them through the GoToMeeting, or you can use the hashtag NWAWEBWED. And I will go ahead and unmute Jennifer Palucci in case she wants to chime in, and Deidre is also unmuted in case there are any comments that she wants to make. I don't see any questions yet. Does anybody have any questions?
So Trish, if there's no questions, I would definitely welcome some comments from Deidre regarding, the impact from her operational, perspective and experience that the dust RGB had, just so that those in the audience there can sort of hear straight from the source there, the value.
Okay, Deidre, do you have any comments?
Kevin, I think you did a really nice job explaining everything, and I think unless you really worked in an area with very large data void areas, the impacts might not be as apparent. But we really struggled with blowing dust. We had very few METAR observations, and although we're a very low population state, especially in the eastern plains, I-40 through the eastern plains is a very high traffic area, and so it is an area of concern for us. So these dust products were just, they were like candy for us. They came a little later, but under every different regime, they would show us the spatial extent of the blowing dust. And we learned about areas that were subjected to blowing dust that we didn't know about. I think the other interesting thing was this concept of elevated dust, where we started seeing reports of broken or overcast ceilings, maybe 2,000 to 3,000 feet up, but no surface obscurations. And if you carefully read the directives, we weren't really sure if we could, in a TAF, have basically no clouds, but be describing broken or overcast ceilings due to elevated dust. And it took us a while to get the answer to that. We had to elevate it to quite a few different aviation offices. So I think, Kevin, you did a great job over the course of a couple of years, and during a period of pretty extreme drought. This product was really very, very useful and interesting for us to use.
Kevin, I do have one question here for you. Somebody has asked, what's the actual link for the sports training page? You've got the name of it on this last slide, but people can't click on it.
Right. So I can hopefully just sort of like bring that up for you. So hopefully it's on the screen there, but so weather.msfc.nasa.gov/sport/training.
Okay, hopefully that helps. I do have a comment here. This is from Ken in Phoenix. We are very interested in this and hope it will help in identifying our dust channel events that we have in the fall and winter here in Phoenix. He's the WCM there. I have another question. Let's see. How is it possible from the RGB technique to determine if the dust is above or below a cloud?
Well, anything that's underneath the clouds, I mean, you will not see. These are IR-based channels that are going in to the product. So if there is a cloud overhead that's blocking the view, that's not going to allow you to see dust underneath. That's for sure. So the only thing that you could try to surmise is that if you happen to have a dust signature there in a cloud-free area that's right next to a cloud, it's possible, or you could at least have an awareness that perhaps that dust extends further underneath that cloud. Perhaps it doesn't. But the only way you'd be able to confirm that if you had a cloud overhead would be to have some sort of other surface observation in that area. So we cannot see through the clouds. These are not microwave channels. These are all infrared-based channels.
Okay. Here's another question for you. Have you compared these RBG images with other products such as GOES, sound, or long wave differences images?
The GOES sounder, did you say?
Have you compared these RGB images with other products such as GOES, sound, or long wave difference images?
I've not compared any of these to GOES sounder products, no.
Okay. The person who asked about the clouds wanted just a quick clarification. So then it does not depend on the cloud thickness. It's just whether there is or is not cloud?
That's correct. I mean, anytime that you might have like a break in a cloud, you may be able to see some of that magenta dust color through that, as we had seen in that one example, which I might be able to go back to if I can quickly sort of take a look at that. But let's see. Right. So so in the case here where we had a dust RGB and we had some magenta coloring going on there, we surmised that there was likely dust of some sort, either from a different plume or from these existing high winds that were happening that you could see in between the clouds, but definitely cannot see underneath a cloud. So if there's a cloud there, you will not be able to see underneath it.
Okay, I do not see any other questions. Deidre, was there anything else you wanted to add, or Jennifer, was there anything you wanted to add?
Jennifer, if you're on, I mean, I think it was interesting. We evaluated quite a few sport products over the years, and we worked hard to put them in GraphicCast and share them. And Jennifer, do you have an opinion for how they were received by the public? I think I remember reasonably well that, you know, we'd use them and put basic explanations on them, and that they helped public and our partners see the extent of these dust storms. Would you agree, Jennifer?
I would agree. I can recall putting them on both Twitter and Facebook posts, and as long as you kind of give a brief description of what each color means, they were generally really well received, as were some of the other products like the Snow Cloud RGB, which we've been using pretty frequently here lately.
Alrighty, well, since in seeing no other questions, Kevin, is there anything else you wanted to add before we wrap this up?
No, I don't think so. I mean, I guess I probably didn't give my email address on one of these slides or whatever, but I mean, if you send something to kevin.fuel@uah.edu, you can also send it to kevin.fuel@nasa.gov. I'll be happy to answer any questions or have any follow-up conversations with you, and I hope that you find some interest in this particular RGB and that you'll look for opportunities to learn about some of the others. I didn't really talk about it in depth, but I'll say that, you know, at first when you're looking at these, it may seem non-intuitive to use these and to interpret them, and I can sympathize with you because I've kind of gone through that process. But the more you use it and the more you keep sort of like that quick guide information in front of you, and you sample those images, the better you will understand it, and it will over time become more and more intuitive to recognize the various features and interpret the various colors. But you know, this new era of the GOES 16 and then future GOES S, you know, they are coming, and there is going to be a large, you know, paradigm shift, I think, in how the various imagery are used. And I can certainly understand people being very comfortable with what they have now in terms of the current GOES single channel, and I can understand the reluctance to want to change from something that works. Obviously, if it works, it doesn't seem broken, so why switch? And I think sometimes it can be, it can take time to demonstrate the value so that you are convinced that making the change from something that works to something that works better is in fact a good idea. So I'm sure you have various tools in your forecaster toolbox, and you know, whatever that is, whatever screwdriver or hammer you have in the toolbox there that you like, I'm sure that it's going to be hard to go away from that. But let me encourage you that I think it's going to be well worth shopping at the hardware store and picking up a new and improved hammer or screwdriver. I think you're going to really enjoy it.
All right, well, thank you, Kevin, and thank you, Deidre and Jennifer, for your input as well. Thank you all for joining us on this February Webinar Wednesday. It's a very timely topic since we're all looking forward to what's going to happen with all the new images from GOES 16. So join us again next month. The March Webinar Wednesday will be on March 1st, and that will be hosted by the NWA Societal Impacts Committee. And I don't have a title yet, but I know they're going to be talking about the importance of consistency in graphics. And I believe Gina Esco is going to be leading that one, so we're excited about that. Thank you all for joining us this week, and thank you, Kevin. I appreciate it, and you all have a wonderful day.
All right, thank you.